We're getting a seasonal lesson this morning. Mr. Jesse Miller joining us from the University of Illinois. Good morning.
Good morning. How are we?
We're good. Ready for fall?
Yes, indeed, and that's what brings us up to our topic today. Although we're actually going to talk about specifically why leaves change color on the next segment, but we're going to kind of lead up to that. We're talking about chromatography, which is an important technique that we use in chemistry to analyze a lot of different things. I mean, and we're going to do the very simple one, but from these simple beginnings come great things later on, right? Sure. You know, everything builds on the other thing. So when you're a chemist and you want to separate some chemicals, it posed to be difficult because, you know, I mean, you have a million, billion atoms, you know, and you can't, like, sort them one by one because, you know, they're too small. And so they're, you know, trying to figure out some way, you know, throughout the years to actually separate things. And trying to chemically separate things is difficult because then it has a reaction and it's no longer the same. And then you'd have to turn it back and things like that. So how do you mechanically separate chemical compounds that are that small? So they came across this idea of separating things based on color. Now, you know, how do you, that in itself is not a mechanical thing. It's something that you see visually. But what it is the things that give compounds color, also the reason why they have different colors is because of different mechanical properties or chemical properties, and you can use that to separate them.
Oh,
so case in point, okay, ink. All right, this is just a green Sharpie. Okay, and if I, whoa, slow down there, Jesse.
Scared me.
All right, so I put a mark on one of these pieces of paper here, just a green, my fingers don't want to work this morning, green mark here. Now this green ink is made up of a whole bunch of different compounds. It's not just like one. If they could find a green dye, they would put just a green dye. But most dyes are made up of several different dyes and they're a mixture. So we all know that green is generally blue and yellow kind of mixed together. Makes it look green. So if we use the idea here between chromatography is you have a solvent, in this case acetone, which will dissolve the ink, okay? And you put this in some acetone, the solvent's going to ride up here through capillary action, right? Just like a paper towel. Right. Right, you put that in there. And as it starts to rise up, it'll start picking up the ink. Now, some of the compounds, because they're different, some of them are, for lack of, some are more polar than others. And if you want to think of it as like sticky, right? Some compounds are stickier than others to the paper or into the compound. So they'll move up slower than the others. And the fast ones will rise to the top and the slower ones, and you can actually separate the components out that way. So what you do, and you can do this at home with water markers, and water as your solvent, and you can put that in there. That's just some acetone.
I mean, well, is this going to be
I'm going to show you time-lapsed. Yeah, well, it depends on how fast it can wick up the paper there. And I already have one here that's started. I started this about 5 minutes ago, if we can get a zoom in on this one. And as you can see here, if you're looking up there, we go. Thank you, Drew. You're the consummate professional. As you can see here, the blue, there's my finger. The blue is rising faster than the other colors. And you can see down in here, we're starting to get some yellow separating out, some bands of yellow and blue. So if you allowed this to go long enough, you might end up with something that looks like this, okay? It's like a puppet show. Right? You get something like this where you can see there's different bands. There's a purple band in there, there's a large yellow band, and the blue band. Okay, and so these are all different compounds, different dyes. And we use this in chemistry to separate a lot of things. Now, nowadays, you don't have to see the color. All right, we have machines that separate things. It's still the same process of things moving faster than others, but we don't look at the color and go, okay, well, this is this compound. We use other types of detection in order to separate those out. Okay, so chromatography is a really cool way to separate this, and you can, like I said, you can do this at home. And it turns out, like inks, you can actually make a game of it, like a detective game, because every batch of ink has its own fingerprint, so to speak. So you can actually tell the type of pen, when it was made, or when that batch was formulated and things like that.
CSI
based on how, yeah, exactly. Based on how it separates, and you can compare it. Like if you had a few pens and you didn't know which one wrote the ransom note, you could take samples of each pen and then match them to the note chromatography.
Oh, you caught me.
Yeah, exactly.
It's all becoming clear, and this leads us into
that leads us into well, how we. It doesn't tell us why leaves change color, but we're going to use chromatography to show why leaves change color when we go back on the next segment.
Very good.
Thanks very much.